So we will see how this goes because I'm the backup to the backup to the backup for this presentation. So I just kind of like did this on the fly, recycling some stuff, and the last half hour. Oh. One moment. Why am I not mirroring? Yep. Screen, yes, things might work. Okay, so you all are getting just this huge wave of information today, right? This is probably fairly overwhelming, but for the next few minutes, we'll just focus on build and test. And I'm going to say up front that this is relatively complicated, but a year ago, I was you, and I'm standing up here now with the shirt I just got from being on the release team for 1.10, so you can do this. So if you're looking to be a developer contributing to Kubernetes project itself, you're sort of like the shipbuilders in this nautical theme that's Kubernetes, right? And there's been a lot of talk about a whole bunch of different repositories that you need to potentially access, but the two key ones for this next segment here are Kubernetes, and Kubernetes Community. So KK has the code for the core of the project. There's others as well. And then the community repo has process, and I'm going to reference a number of things in there. So for your development environment, there's a whole bunch of different ways to do it, and I think it would have been fun to have this talk be like 3 or 5 of us up here with our computers in parallel showing stuff, because we would have all done it differently, I think. So this can get a little opinionated, and I'm going to try to not be like opinionated or negative, but again, like this is complicated, and there's preferences and stuff. So I'm standing up here using a Mac, and I'm going to say use Linux. I think you'll find that things are easier as a newcomer. There's less to orient to, but I'm going to do this on a mix of Linux and Mac just to show that it's possible. A quick show of hands. Windows users? 0, literally? Wow. Linux? Yeah, right on. A good chunk of you. And Mac? And is there anything else? Is there other? Okay, making sure I covered them. Okay, so I personally don't have experience on Windows, but I'll show a little bit of Mac and Linux. The biggest things are you need a fair amount, a lot of RAM and CPU and disk space if you're doing this stuff, depending on how much you're doing. The official documentation, I think it recommends like you want 4.5 gigs of memory to successfully build. I've tried building with way more than that and fail with resource errors, so your mileage may vary, but one of the cool things is that it's an iterative build. So if you build and something weird happens, just like arrow up in your shell and hit enter, and you'll probably get further. And I have literally never not had it succeed, even though it feels weird, and it's not what you'd want for the best of experience maybe from a newcomer, but have a little confidence, trust, retry, and I think you'll see that you're progressing as you go. You also are going to use a lot of disk space. So one of the potential problems, and let's see, does this work? Oh yes, it does, cool. Can I type my own password? Not in front of people. Let's make this, that's way bigger than it needs to be. So I gave this virtual machine, I gave it 8 gigs of RAM, and oops. I've got, I think I gave it, yeah, 8 cores. So that's a fair amount for a virtual machine. And if you're running on a Mac and you want, or Windows and you want to play in Linux, you might just start out with like giving it 1 core and 1 gig of RAM. Not gonna be a happy experience. So think about the sizing of your machines and that they need to be kind of hefty. Now the other big gotcha is that so familiarity with Go. I wasn't in here earlier, I don't know how much Golang has been talked about, but how many of you feel like you're proficient in Golang? And relatively new? Okay, so kind of half and half, that's a good mix. So anybody who's not touched Go at all? Got a couple people. So as you set up a normal Golang environment, one of the things that you're going to set up is your Go path. And underneath that, you will have a directory called source, and within that, if you've done a Go get of various things, there's a whole sort of hierarchy of code. Kubernetes is expecting to be in your Go path source kates.io/Kubernetes, and you'll get some odd build failures potentially if you're not there. And then the other thing that I would mention is if you're going to start doing substantial work, you need to think about what's going to be your test cluster. Are you going to have Kubernetes as a cluster running somewhere in a cloud? As you build code for the cluster, where are you going to put that code to run and test? And those, again, could need to be substantial depending on what it is you're trying to test. It could be very little. There's multiple ways to do things, but it's domain specific. If you're trying to do some big scalability test, obviously you need more than if you're just trying to make a small CLI change on the client side. So what next? Oh yeah, Golang. So I'm gonna do actually a little bit of demoing here at this point. And with some luck, this will actually work. I think that's probably big enough. So for my basic development, I've got a directory called source, and I've got random stuff on there or whatever. I've got a bunch of GitHub stuff, and Kubernetes is one of them. I've got a bunch of repos checked out. I go in there, and I try and do something like build, run, make. Oh, error. So the first thing that you bump into is that the build happens in Docker containers. So if you're on Linux, you need to install Docker and start up the services. If you're on Mac, you need to fire up Docker. And it takes just a moment, but I wanted to show that so you see, like, you actually get an error. It reminds you that you are supposed to be using a Docker environment. And then I was starting to type this command, run.sh, and make. Like, if you're used to Go, you're used to doing Go build probably. And I've got some shell script, and I've got make, which is like old style Unix. Like, what's going on? This is a very big project, so there's a bunch of build tooling that's been built around it. And I think my stuff is running, so I can rerun that. And you see that it's using Docker for macOS. It's starting to build some Docker things and get stuff going. So the build can take a really, really long time. And I'm just gonna cut to the chase on this one. So this build is actually gonna fail. Oh, there we go, we started having some errors. The build is failing because if I look at my Go environment variables, I've got my Go path set to the Go directory, and I tunneled down into just where I stick my normal sources. So I need to actually go into my Go source, and it's case.io Kubernetes. And there I've got, it's the exact same stuff, but because of how Go things end up working, it expects to be more in that Go environment. So I run that again, and I guess I could stand here for like 5 minutes and talk and just let it fail to show like it probably is gonna fail, and then do like a few iterations. But the point is that it's usually you get some failures, and if you just keep running that, oh, that's not readable. If you just keep running that command, it's gonna converge on success eventually. Trust me. As a software engineer, like, I'm sure if there's a computer scientist in there, you're like, engineer. As a software engineer, I don't feel entirely happy about this, but it generally works. And actually, because most of my stuff is built right now, that all sailed through the compilation phases, I think, and it's now getting into linking. And usually I have link time failures around resources, not enough memory probably, but that's where eventually you can kind of iterate. But I'm just gonna kill that, and hopefully it actually dies. You don't have to build everything though. So you can do a command like this, where you say, I wanna make a particular thing, and you say, make what? And since this is in the process of dying, I'm gonna just go back over here. Where's my virtual machine? I have to keep typing my password in front of it. Ooh, I did it right. Okay, so same thing here. If I cd into my Go path, and it was source, I think, right? Yes. K8s.io, Kubernetes, I've got my stuff there, and I can say make what equals command kube control. And it's going to make just the kube control binary. So that should go relatively quick. Oh, that's not happy. Why would that be failing? I just literally double-checked that all of these commands worked. That's still not dying. See, this is proof that it's complicated. I'm in my right spot. I'm missing something for a prerequisite. Normal build is working. Make what equals kube control. Oh, so while stuff is going, I wanted to actually, so I'd reference where the code is, right? The other thing I wanted to talk about was where documentation is on this. So everything that I'm doing right now is just coming from this URL. So that's not super easy to see. It's not making it bigger for me. So this URL, that's relatively readable. So you can either go to github.com/Kubernetes and tunnel around into the tree, or if you want to type it more concisely, git.k8s.io/Kubernetes/build. That directory has a variety of build tooling, but build documentation. So the set of commands that I was demoing here, these are basically the initial ones that are described here on the page. So the one other thing that I wanted to touch on was, so assuming you get that built, and now that's hung. So another thing talking about resources. So I've got my Mac running, I've got my virtual machine running, and I've got Docker for Mac running. Docker for Mac is running a virtual machine for Moby Linux and its stuff. So I'm absolutely cratering my poor laptop right now. But I think this is, it's useful as an example to remind you, like, if as a newcomer, you're gonna run into resource issues, things are gonna kind of fall apart a little bit. So try to start simple. If you can do something like for an initial build, try to build the kube control command, add a little hello world print line at the beginning of the kube control. And then when your binary builds, so if I'm building on Mac, I have my kube control that I built right there, and that, so on the left you can see the directory where it output just as I was building local stuff. I can run that command. So if you've managed to successfully build that and you'd put some little format print line or something at the beginning, you'd see it, and you know that you actually built your stuff, you got it in there. So you can do sort of like a little simple hello world-y test where you've modified something completely trivial, built something small instead of building the entire Kubernetes, and see that you've got some success there. One other little gotcha that I'd call out, depending on where you're building and where you're running and testing, these could be different environments. In Go, you might think, well, I've got a statically linked binary, but you can't run a Linux statically linked binary on Mac. They're two different OSs. So you can actually say kube build platform and say, I want to build for Linux, AMD 64, or you could say for Darwin, AMD 64. So you can do cross-building for different targets. So that's all I'm going to do minimally on build, and then just touch very briefly on test. So the jumping off point that I would recommend for test, so the URL is up there. and I think this URL has probably come up multiple times in the day. I'm sure Gwen and Josh have talked about it, the Community Contributors Guide. Inside this document, there's a whole bunch of useful bits of information, but one of them here is testing. And if you jump to testing, it gives a little overview of the different types of tests. So you've got your basic unit tests. These are just normal Go tests. If you've got your Go source file, you've got your _test.go file next to it. That's what this stuff is. You can run it locally, piece of cake, no big deal. Then there's also integration tests. These are ones that are going to depend on something else. So say you have a test that's going to, you have code that's going to talk to etcd and you want to test it. You actually need to stand up in etcd. You can still run these locally, but you have to set up whatever that dependency is and be able to talk to it for the test. And then there's end-to-end tests, and those get much more complicated. Those are the types of things that Sen was showing a few moments ago, where those are the automated things. You make a commit, some sort of cluster is automatically stood up and things are tested against each other. So I'm going to just cover very briefly the Go unit test. Okay. Okay. So this is pretty straightforward. So again, I'll mention, like, if you're in the wrong source directory, things are going to fail. But if you're in your Go path area, then if I jump down, for example, into cube, where am I? kubeadm app util, I can literally just go test like I would normally. Go test ... And it's going to run. It's going to. It takes a few minutes, but it'll spit out tests. Or actually, this one's fast. It spits out stuff just like you'd see with normal test. Now, that's Go native, but like the building stuff, instead of doing Go build, how there's these make things, there's also a set of make commands that are related to tests. So there's sort of the Kubernetes way. You could make test and say what for a particular thing. And that, so I have a failure here because I'm down in the tree and there's not a make file there. So I have to go back up to the root. And there I can run a make test command. And the, so this doc that I referenced, it also has a link off to another testing document. So this is sort of just the approachable single page of text on orienting to text test, but there's a whole other document that goes into a whole bunch of detail on all of this stuff. And then there you can see that my make test, it gave different output, and this makes sense because the output is oriented at Go, not at just the Go developer, but at a Kubernetes developer and Kubernetes automation that's going to consume things. So it looks more like a, almost looks like JSON-y sort of output or something, but that's sort of a very quick intro to building and testing, and if you have questions, I think Slack is probably the best place, but those docs that are out there from the contrib guide, you can get into the build and test docs. And good luck, be patient, it's definitely complicated.
Thank you.
Thank you so much, Tim. All right. Actually, let's just go ahead and... Nice. Well done. This is it.
Hold on, it hasn't come up yet.
Present.
There we go. Ta-da.
Ta-da. All right. So we are all so glad you came to this workshop, but we are even more excited to have you all stick around and stay and contribute, and we really want to see your faces, and we really want to see you asking questions. And we really want to see you here the next KubeCon telling us what to do about your special area of expertise. So please attend the SIG updates this afternoon. Maybe you have a better idea of where you'd like to get started and just kind of dive into. There are introductions and there's also deep dives. Pick and choose. Come ask questions. And please do pursue that membership that membership. Once you're ready, please find people, please find things to work on. This is my, I think this is one of my first PRs, and you've seen all that needs okay to test label, so we'll take that away from you if you are a member. And let's come back to that original membership structure. We want to have specialists on all levels of this code base. And before you think, oh my goodness, I have to learn everything about Kubernetes in order to become a code owner, that is not true. You can be a code owner in one area and just a basic entry-level member in another. It just depends on what you're good at and what you've worked on. We already mentioned this. And I think it's, and I think,
Sorry, I left out one thing, which is you need to join the Kubernetes dev mailing list if you haven't already.
yep. Meetups. We already talked about that and this is one of the things, please go search out mentoring opportunities. We are working really, really hard to mentor new contributors, perhaps on a more personal basis rather than a big workshop like this one. There is group mentoring. There's an entire folder in the community repo that talks about mentoring. Please feel free to go and find out what that's all about. A really great way, I am told, I haven't done this yet, to get involved is to shadow someone on the release team. People are always looking for help on the release team. Then there's, of course, if you are still in school, if you're a student, or if you're a non-traditional contributor, there's Google Summer of Code, there's Outreachy, but those are limited to certain populations. And then finally, thank you for being here. I am very excited about the rest of the conference and hope to see many of you around. If you want to get in touch with us, here's a contacts page if you want to take a photo or anything like that. I'm around the internet a lot, so hopefully I'll see you there on Slack, on Twitter, on GitHub, definitely on GitHub. Yeah, and thank you for being here. This is the end of the workshop. Give yourselves a hand. This was a really long